Dear friends, dear colleagues, this is a presentation I gave in the meeting Soils for Our Future that was held in Winnipeg, in Manitoba, on the 20th of July of 2025, during the meeting of Division 1 of the International Union of Soil Science, dealing with the future of soil micromorphology. Why soil micromorphology? Well, morphology and micromorphology of soils is one part of the observation of soils. Soils is a continuum of observation from the landscape to micro or submicroscopical features. So morphology and micromorphology cover the part of observation of profile, observation of materials, and it requires for the more detailed scale the use of microscope. Why is it important? It is important because micromorphology is like, for instance, anatomy or plant physiology for the botanists or anatomy for the doctors. So it's impossible to understand how a body works without knowing the parts of the body and how these parts relate to each other. So it's exactly what micromorphology does, identifying the elements and seeing the relationship between them. A brief history of micromorphology. It was initiated by Walter Kubiena, and it was thanks to the book Micropedagogy in 1938. In his proposal of the classification of the soils of Europe, that is a classification that has a genetic approach. It is not used anymore, but it's a genetic approach. He was the first who introduced the characterization of these soils with micromorphology. In recent decades, it has been extended, its application not only to soils, but to archaeological sites and to new fields, as I will explain later. Later on, the first person that was systematizing the description system, the how to describe thin section, was Roy Brewer from Australia, who applied concepts of mineralogy petrography to the description of soils. So he was the first to introduce, for instance, concepts of bifabric in another way, that were later developed by other micromorphologists. Also very noticeable is E.A. Fitzpatrick in Aberdeen, who did an excellent work describing and interpreting thin sections, of thin sections of an excellent quality. And it is in several books on micromorphology of soils, till this one in '84, where he explained all these findings on interpretation of soils. It was in '85 that the Handbook for Soil Thin Section Description was published, thanks to an initiative of the International Union of Soil Science that saw the need of an integrative international system of soil thin section description. Thanks to this international group, Peter Bullock, Nicholas Fedorov, John Geriu, George Stoops, and Tatiana Turshina, with other persons, other micromorphologists who contributed. This handbook has been widely used by many micromorphologists in the world. In the recent decades, in this decade, George Stoops, one of the co-authors of the Handbook for Soil Thin Section Description, published two updatings of the system because some concepts still were not completely useful or completely explained. So he published in 2003 an updated of this system. And the last updating was just a few months before he died in 2022, the second edition of the Guidelines for Analysis and Description of Soil and Regolith Thin Sections. So this book should be seen as the equivalent for soil profile description to the Soil Survey Manual or to the Guidelines for Soil Profile Description of FAO. George Stoops with Vera Marcelino and Floria Smith edited in 2010 a book of interpretation of micromorphological features. So it's not only the description, but they were updating or making this effort to compile all the findings on interpretation of micromorphological features of different fields and different materials, written by the specialist in each field. This book on interpretation was updated in a second edition in 2018. Walter Kubiena was the founder of micromorphology, as I have said, and he discovered, or he was surprised on how micromorphology could explain the complexity of soils and how it could help. So he said that it was the only way to disentangle the complexity of the soil organization. And he gave the analog of the clock. If the soil has components that relate to each other, one way of studying it is with a mortar, making it to powder and making thousands of analyses of this powder. Will this analysis explain us what is a soil or how it works? No, or very little. What we should do is how we study a clock. We would open the clock and very carefully, without disturbing this clock, seeing what are the components and how they relate to each other. So this will be the way to know what a soil is and how it works. Techniques to study micromorphology. The basic techniques are the study of soil thin sections. They are normally bigger than the ones used in petrography because in large thin sections, it allows to see the different structures. They are impregnated with resin, hardened, and cut to standard thicknesses and polished to standard thicknesses of 30 microns. And the observation of these thin sections, it can be done normally with line microscopy, with parallel polarizers, cross polarizers, but these thin sections also can be seen with electrical microscopy and the other different techniques. Also, the industrial blocks can be seen with techniques as CT, computed tomography, which allows to see mainly the pore space in 3D systems. What can we see? In a few words, without pretending to go through all the guidelines for soil thin section description. It allows us to see the microstructure, how the particles are arranged. For instance, the first picture is a tropical soil with a typical granular structure at the right side, and in the left side we see this structure that has been compacted. In cross polarizers, we can see the B fabric, which is the birefringent fabric, which allows us to observe how the clay particles are arranged. And finally, pedofeatures as these nice clay coatings, which shows us that this clay has been eluviated from some horizon, which is overlying this material. And the application across disciplines was studied by George Stoops in one of his papers and in an updating in 2022 for a chapter of the Encyclopedia of Soil Science. We see that in the beginning it was mainly used for pedogenesis, but very soon other disciplines as paleopodology, archaeology, and also agriculture saw that this technique can be very useful for its application to wider aspects and wider fields. We see, for instance, at the part of methodology of making thin sections that there would be in others has been decreasing, and archaeology is and paleopodology is almost half of the publications, or it's nearly half of the publications. Agriculture is very small, but this is significant in very steady because it gives us information about soil structure and other soil components. How soil micromorphology is taught? Yeah, unfortunately, it is not normally in graduate curricula, and it is taught in specialized courses. The first specialized courses or intensive courses were given in Wageningen, thanks to a wide and long Erasmus program that lasted till 2001, about 1 decade. And thanks to these courses, which lasted for 1 month, they were given in Wageningen, in Gent, in Granada, and also in Portici, the last one. After that, George Stoops in Ghent, he was giving every year some short courses. And also, we were given some 2-week courses in Barcelona, in Tübingen, in Medellin, Colombia, in Zagreb, in Bogota. And the last ones have been in Trem, near Lleida, near my university. And the last one has been in October 24. The next course would be programmed hopefully in September, October of 2026. Besides these, there are short courses 3-4 days before the micromorphology meetings of Commission 1-1. And they were in Lleida, in Mexico, and also the last one in Puno last December. The meetings of Subcommission 1-1, they are very, they go back to the 60s. Yeah, the Commission 1-1, it was not under this title, but the Commission 1-1 is the heir of the first meetings of micromorphologists within the IUSS. And in the last years, they are held every 4 years, except the one in 2020, which was not held because of COVID. Yeah, this picture here is the meeting in Lleida in 2012. The next one, hopefully, will be held in Poland, in Krakow, on 2028. The Commission 1-1 Zoomorphology and Micromorphology has a web page, with chair, it's Fabio Terribile, and vice chair, Adam Sorba. And you can access this webpage that it's updated periodically. What are the applications, the modern environmental challenges? Well, I have chosen a couple of examples. The first example is one of the fields we work at the Faculty of Agriculture and the School of Agriculture in my university, which is the study of porosity and structure when you apply different types of management to the topsoil. You see here, for instance, after applying fertilizers or sludge compost or pig slurry, you see indeed a strong change in the structure and porosity. Here is the counting of the different types of bioturbation that you can encounter in these thin sections and how this management affects the porosity and structure. Another challenge is geoarchaeology and paleoenvironment. For instance, here's another application of the study of structure in a project we had on the evolution and pedogenesis on Loess in the south of Catalonia. We saw that the process of loessification, so the formation of a soil, a paleomaterial soil from loose aeolian dust, is simply a process of packing. Yeah, and this is seen by the study of this porosity in relation to the age and how these dust particles are progressively packed to give a more compact structure. Some challenges that we still have to refine and to demonstrate you that there are still many, many things to discover is that very often I still find some features that I don't find back in papers or in surveys. So, for instance, these particles, the round particles surrounded by clay and silt coatings that are independent or not related to the surrounding ground mass that I interpreted as part of a colluvium, yeah, but this has never been described. Or, for instance, some features in horizons that are not completely characterized under the micromorphological point of view, like, for instance, BT or NA horizons, so natric horizons, which are very difficult to, it is very difficult to observe clay alluviation. The clay alluviation in very nice stratified, micro-laminated clay coatings that we see in normal BT horizons, they are very rare to see in BT and NA horizons. And also, for instance, other horizons that are not very widely studied as nitric horizons, sombric horizons, phragic, duric. So we have still a lot of work to do with them. Also, there are some features that start to be studied, as, for instance, the relation between living organisms and a mineral material other than structuration and porosity. For instance, in this Paleosol project, we saw and we studied the biomineralizations. These are calcification of old root tips that we find in paleosols. But with this observation and the study of these features, we have been able to plan some experiments trying to mimic or to reproduce these features as a possible mechanism of inorganic carbon sequestration. without micromorphology, you would never think about this. Besides this, training challenges and future directions of micromorphology, we have to reinforce training of micromorphologists because the observation and study of thin sections require some training and some hours in front of the microscope. Also integration with new techniques as computed tomography, that allows the observation of the whole volume of the soil, and also artificial intelligence that can help to recognize features and help us to make interpretation of thin sections, given that we have a wide enough database of images. Yeah. Also, emerging contaminants as sludges of microplastics, as the one you have in this picture. There is a lot of research to do to see how they weather and how interact with soil components, and also the role in climate resilience. So as conclusions, yes, there is still room for micromorphology, and also not only because of all these reasons that I have given, but also because this is wonderful as this picture shows. Thank you very much.